Here's the introduction to Chapter 13.1, Comparing Three or More Means. We call this Analysis of Variance, or Anova or Anova. And so what we're looking at here in this case, comparing to what we did prior when we compared two samples with each other. We really started with one sample, and then we did two samples, and now in this case, analysis of a variance or Anova. Again, this is part of inferential statistics, and we use it to test a quality of three or more population means. And so the null hypothesis, right? The null hypothesis is that, in this case, the null hypothesis is for analysis of variance is that the mean of 1 equals the mean of 2 equals the mean of 3. What we do not want to test, let me rewrite this here. What we do not want to test is this. We do not want to test three separate. This is the good one here. We do not want to test that the mean 1 equals mean 2, mean 2 equals mean 3, mean 1 equals mean 3. Those are three separate tests. And by conducting three separate tests like this, do not do this. You increase the probability of what we call a type 1 error because you're doing multiple tests. And so remember, there's always a chance for a type 1 error in any test. So an analysis of variance is just testing. That's what an Anova is, right? And do not test this over here. Of course, there are some requirements for a one-way Anova test, and they're stated here. You can go ahead and read those. There's, again, a lot of technical things. Of course, in this section, we will pretty much be meeting the requirements, so we'll just be running the tests. You just want to be mindful of that. There are some technical details involved in running these tests, and when you do statistics or you go on your next class or do some research methods class, you will have to be attuned to these ideas. The one that we're going to kind of test later on here in this would be the populations are normally distributed. But again, all of these are important factors in the requirements for an Anova test. One thing that we're doing in an Anova test, here's an example of an Anova test right here, testing three means. Here is your null hypothesis, and this is your alternative hypothesis. This would always be the alternative, that one of the means is different. And there's a picture of it. So if you have three samples and their means are the same, you can see that the curve, they'll have similar normal distributions and curves, and the means would be all together. If you have samples with different means, notice how the distributions, you'll see that these means are located at different places. And so this is a visual of an Anova test, a one-way Anova test. When we use a one-way Anova test and we use the procedures, the methods we use are, we say, robust. They work pretty well, even if there is a small departure from normality. Remember, all of these tests only work if our data is normally distributed. All our rules are connected to this, right? And so that's important to remember as we do this. And again, as you move forward in doing your own research or take another class in the future, therefore, as we're designing an experiment in which samples from the population are roughly equal in size. It's important so that we can kind of run these tests. But again, they have these requirements, and then but for this class, we'll kind of assume that those requirements are met. Now, the one that we will check that comes up often is testing for normality. And so here are the instructions on StatCrunch. I want to show you, we're going to do that on the next one, but this is the instructions. And there's a general rule of thumb we use when you run this, that you look at the correlation coefficients of the data that we have when we're comparing them. And we'll do that on the next video.